Hi everyone. Um, Now I'm going to continue our discussion based on the last handouts I shared with you lately on LMS or maybe through other material. So if you remember from the decision-making process that I'm trying to teach you here in this course, we call it data-driven decision-making. And as you notice that I was focusing on both directions, top down versus bottom up, and I explain everything in previous material, whether video or maybe text based or handouts like a PowerPoint or so. If you remember as well, based on the case study that we started, Sphinx business or Sphinx online business, we basically build the framework, and the framework, if you remember, consists of the dependent variable, which was X19, the overall satisfaction of our customers. And we have the independent variables, which are around, or they are actually 13 independent variables, came from the 23 variables. So go back to our previous discussion to know the story of Sphinx, and we have another 5 variables here that are categorized as Z variables, where they are moderating the relationship or the relationships between the independent and the dependent variables. To continue with the pyramid top down, once once we reach the framework, we will come up with the 3 families of questions. Where are we, or whether our customers are happy? So we need to benchmark each variable in the framework against its own benchmark. I'm going to show you that during our session today or maybe some other time. The second family of questions where we want to know how we reach the destination, because the question number 1 is basically answering the question of where we are and where we want to go. As for the second question is how we go there, which translated based on our data set here, that or based on our framework, what are the most influential independent variables that have the most effect on the dependent variable, in this case X19. When it comes to the last question, which is a third family of questions related to the effect of moderating variable in this case. So now it looks like we will have, based on this slide, or based on the pyramid, once we finish this, the formulation of the questions, by now we know which data to be collected. So I'm going to show you that later on, and this is the data. If you remember from the case study that I shared with you guys, those are the list of variables, and even if you go down here, you will find out how we measure them. We discussed that in one of the previous sessions, so you have to go back to it. We collected data, or at least we pretend that we collected data for 100 customers. So this is the data set of 100 customers, and all columns are the variables in the model. So Z1 up to Z5, they are the moderating variables, and from X6 up to X18, if I scroll like that, those are the independent variables, and this is the dependent variable X19, which is the customer overall satisfaction. We also got another variables from the consultant, if you remember from the case, but we didn't include them in our framework for that reason. We will not use them, at least now, or at least for this session. So this is the data set. If I go down here, you will see that we have 100 customers. So it's very obvious we have 100 customers here. Okay, so if I go back to the slide sheet here, so to continue, what we're gonna do now. Before really going to the analysis of the data that we have, I want to discuss with you very quick uh, important concepts here. So I'm gonna show you how we see the world from population and sample perspective. We want to differentiate between parameters and statistics. So they are very important terms. This, the branches of data analysis that we're gonna cover here, which will be between descriptive versus inferential. When it comes to descriptive analysis, we're gonna go through numerical analysis and graphical analysis as well. I'm gonna show you that. Let me, before I depart from this slide and go to the data, it's very good to talk about that. So at least from now on, we will have two very important branches when it comes to data analysis. We have the descriptive analysis, and nowadays everyone is calling it descriptive analytics. And in descriptive analytics, we answer questions in the past. So what happened, right? So the data set that I showed you here, it was already collected, so it's in the past. So basically, any analysis we get from the descriptive analysis, it will tell us what happened in the past already. But it's important to know what happened before trying to predict what's going to happen, which is the second branch of data analysis. We call it inferential data analysis, and nowadays everyone is calling this branch predictive analytics. And in predictive analytics, basically, we will have a list of tools that will help us a lot to answer questions in the future, and basically for the population and not for the sample, because the descriptive analysis, it's basically focus only on the sample, but there will be a way to generalize the results from sample to population. So we're gonna come back to every now and then to this slide to show you more details. This may be a very critical slide, and I would like guys to try to pay attention to here to this point, because it will explain a lot concept that we're gonna cover during this semester. So yeah, if you look at in the middle here, if you look at the middle, you will find that it looks like a table of data that already came from data collection process, and this data collection process will bring us this data set in the middle, and we're going to do and perform a couple of analyses, usually descriptive at this level, and then we get some values here. These values will be basically representing, or will be representing true values, because you can see here this data set. We're going to call it sample here because it's not the whole database of all customers that we have. At least it's a list of or subset of it. So basically every time we change our data, or if we get new data, these values on the right hand side will change. For that reason we call them statistics, because they are changing, but in the end they are representing something that we hope to get, which is the true value. So that means we're always aiming at finding the true value of maybe the average satisfaction, or maybe a certain distribution of data. But since we are working with data set only, not with the population, we will always guess. We are always guessing what's happening in the hidden world here. And the hidden world, I call it population, because the population where the truth is, and always the truth hidden. And we as human beings, not only decision maker, we are actually sitting on the right hand side of the wall. So if you can see in the middle here, or on the left hand side here, like a visualization of a wall to show you more or less that basically we are on the right hand side. We try to guess what's happening behind the wall, which no one is going to know exactly what's happening, but we always get data to guess what's happening here. So getting data, it's a sampling techniques. We're gonna go to talk about sampling techniques, especially and criteria later on in this semester. But for now, I think you understand what does it mean sampling basically. So it's related to data collection. What we will have in hand after sampling is a sample, which is set of data points. In our case of Sphinx, we will have 100 of them. Um, then we analyze them, and we're gonna get some data, some values or some information here, because we are going to summarize them. Summarize a lot of data points here. If we have 100, sometimes we might have million of data points, but we are not interested in the details, but we are interested in summarization. And this summarization of our data, we call them statistics, or basically information. And since they are not coming from the population, then we call them, they are the estimation of the truth. For that reason, the slides, we call it here estimation of truth, which means every single thing we have here will be basically estimation. But when the information that we got, or the summarization that we got, we call them statistics, then the next question could be, what would be the name or the label for the true value? The true values, which will be the characteristics or numerical characteristics of the population, we call them parameters. As you can see here, there are a lot, but I selected only 3 to make it easier for you to understand the concept. But we can expand the parameter list into many parameters. Again, parameters are the characteristics of the population. Statistics are the characteristics of the sample. And you will see like mirror here. So X bar is the average of data. Mu is the average of the population. Sigma square here on the left hand side is the variance, and sigma is the standard deviation, and sigma squared is the variance. Anyway, both of them, they are the variance or standard deviation of the population, and we call them parameter. Pi is the proportion. It's like a percentage of, if you have a categorical variable split into 2 portions. One of them is 50, the other one is definitely 50, or maybe 60-40, or any other combinations among this proportion. So we call them pi. So if you look at the sample side, you will see that we have the same concept, or the same items. Like we have average, we have standard deviation and variance, and we have proportion, but we call them differently. When it comes to parameter, we use Greek letter like mu, sigma square, pi. But when it comes to sample and the statistics, we use the Latin names like X bar for average of the sample, S squared, the variance of the sample, or S, the standard deviation of the sample. P is basically the proportion. If I go down here to show you that we have 2 types of data. We have qualitative data, we call them non-parametric, and the usual name that everyone knows about it is called categorical data. But if we have metric data, where they are numerical, we call them quantitative data as well, and they are numbers, not in categories here. In categorical or numerical, underneath each one of these, we have 2 different scales. So we have nominal scale here, and we have ordinal scale here. So we have 2 scales here, nominal and ordinal. On the other side, in numerical, we have interval and ratio. So we're going to talk about that sometime in one of the sessions, to differentiate between nominal and ordinal, and interval and ratio. Nevertheless, your task is to go back and look at the material that I share with you to see the difference, especially in my handouts. They are there. So because the focus today is to show you something on Excel, not to invest much of time here on explaining the concept that are already explained in different handouts. If we want to look at the landscape of descriptive analysis, which will be the last slide before going to Excel to make some analysis for you guys to show you some of interesting functions and formula and tools. So if you look at the descriptive analysis in the middle here, on the top you have graphical representation of the data, and on the right hand side you have numerical data or analysis. So for graphical representation, it depends on how many variables you are linking together. If you are working on only one variable, sometimes we call it one dimension, and here it's abbreviated to one dim. Dim, it's a for dimension. If you have two, like two dimensions or two variables. So when it comes to one dimension, we're going to talk about histogram for the shape of data and box plot for the position of data. So I'm going to show you two things today because we are going to work only with one dimension at a time, although we're going to do the same thing on every variable, but still we are not making the linkage among the variable now. We're going to do that later on in the semester. But I'm going to show you graphically how, when you have a data, what you're going to do with it by constructing histogram and what the histogram means here. The same for another very critical and important and well-known nowadays called box plot as a tool to basically give you more and more information to help making good decisions. When it comes to more than one dimension at a time, like correlations, for instance, we will need to use what we call scatter plot if we have numerical data, but if we have categorical data, we're going to have a cross tabulation. It's something similar to a pivot table. When we go to the right hand side, the numerical side here, we will have four branches. Central tendency of the data, we're going to go to show you the mean, the median, the mode, the mid-range. I'm going to talk about that today as well in terms of numbers. Also, we're going to look at the variation of the data from different perspectives. So we can look at the data from the variation in the data based on the variance as an index, or a standard deviation, which is definitely related to the variance. We're going to look at the range, and we're going to define every and each of these in front of you, and to understand what could we get from each of these, because the idea is not to use all of them at once. Sometimes you need to be selective. What do I mean by that? I mean you might need to look on which of these will be more relevant to your project of data analysis. Another two, unfortunately, are not well known, but they are very extremely important when it comes to data analysis, and most of the decision makers or executive or data analysts, they don't really pay attention to them, and I hope I can show you this semester how important they are. And they are under the branch of shape, of finding the shape of the data, and we call them skewness and kurtosis. I'm going to talk about that later. When it comes to the last branch or last direction of data analysis, or next level of data analysis, called positioning. So we need to probably go toward what we call standardization of the data, when the z-score is one of the very popular methods to standardize data and basically to know where your data points are. Percentile and quartiles are interesting concept that we need to focus on soon. So I'm going to show you in a minute about how, or the next step, I'm going to talk about data analysis. Now I'm going to take you to the data set here. And here in data set, we have all variables, as I told you before. And we need here to analyze our data. And the first step to analyze data is to know what type of data we have. So if I go to the sheet variables here, And by going down here, and you have that on the PDF anyways, if you go down here, you find out that there are each group of variables uh, are explained in how they were being measured. So, for instance, if you go down here, you will find out that all data from x1 to x5, they are categorical data. Why they are categorical data? Because they are, consist of categories. And you can see here, you will find out that 1 to 3, which is just label and code, they are not values. So basically, you cannot calculate average for this variable, right? So if you have 100 people and you get the average of 1 to 3, you will get number like decimal point, like maybe, I don't know, maybe 2.1 or 2.2. Doesn't make any sense here, or doesn't mean anything. So for that reason, categorical data, we cannot really use this kind of descriptive analysis except just proportion, how many people in category 1 and how many people in category 2 and so on. The same for gender, age group, and here as well as the location, and also in here in payment method. But anything else in this sheet, if you look at the definition except 23, you will find all of other variables are numerical values. And if you want to know that, you can go to the data set. You can see here x1, I rename them z1 in order to relate them to the z variable as moderating. So z1, z2, z3, 4, and 5, you can see the values here are not actual measurement. They basically code or label to differentiate between different categories. So here we have only 2 categories. We call them 0 and 1. For Z2, if you remember, this was the gender, and so on and so forth. But starting X6, you can find decimal points here. And based on our measurement technique, it was obvious that we allow this decimal point to happen to make the measurement more accurate. So it's basically numerical. So from X6 up to X18, and we can include X19, it's part of our framework. All of them, they are numerical data. If you want to check that, please, when I share this sheet with you, you can go ahead and go to this variable sheet, or you go back to the case study, the PDF that I shared with you some time ago. Okay, so now we know which data we have, numerical or categorical. So based on the framework, if I go back to the slide here and go to the framework very quick, I found out that the dependent variable was the X19. So it makes very good sense that we start with X19 as a starting point to describe the data. So this is exactly what I'm going to do. So I'm going to go ahead and go to the data set here. And in order not to really destroy this sheet of data set, I would prefer to take only this one, control copy, and I take it and paste it in a new sheet like this one here. So now you can find out here it's a new sheet. So let me make it a little bit bigger. So I made it a little bit bigger here, just for you guys to see it. So this is X19, which is the customer satisfaction. And just not to make our video longer today, so I will continue later on, but I'm going to show you very important things when it comes to data analysis very quick. So I can use built-in functions, or I can use one of the built-in tools here. So if I go to the data tab here, if you can see here, data tab, on the right hand side in my computer, you can see the data analysis and solver. If you try to do this on your computer or using your Excel, maybe if you used it before, you will find it still there. If you didn't, then let me show you how you get this one. So to get this data analysis and solver, you basically go to File tab here, and if you go to the very bottom of this sheet, basically I'm trying to find something called options, but I don't find it, so you can find under the more option here. So if you push more here, you click on it, you're gonna find some more. So this more that I'm trying to find is the options, so I'm gonna go ahead and get the options. Once you click on options, you're gonna get this screen. All what you need to do is to find on the left hand side here the add-ins button here. Try to click on it, and once you click on it, you're gonna get a totally different view like this one. Okay, so you get that. All what you need to do, you don't to the good thing is you don't need to do anything except to push the button here. You see here, go button here, down here below the screen. So if you push on it or click on it, you're gonna get this dialog again. You can see here there are two boxes here, check boxes. The first one is called data analysis and solver, and that's why you find here on the top right of my screen both of them are there. So if you want, in your case they are unchecked, so basically you check them and you push OK. Once you push OK, in a few seconds you will find them here appearing in this exactly the same spot here. So I'm assuming that you did this, so I'm going to go ahead and select the data analysis after you installed it. So once I do it, I'm going to get a list of tools here. This list of tools, you'll find multiple tools. Some of them they are very basic, some of them they are totally advanced. During this semester, we're going to use some of them, not all of them. So, and obviously the most important one, if you start from the top, if you go down to the 6 options, you will find the 6th option here is called descriptive statistic. And since we are learning in this semester descriptive statistics, this will be very important aspect. So what I'm going to do now is select this, and once I select it, I'm going to get a new view here where I can select the input range, which is obviously will be the column A. So I'm going to write column A here as it is. Of course, if you are familiar with Excel, you can use a lot of shortcut, or you know exactly the reference. You can do whatever you want here, but sometimes I'm gonna go to do what I feel like could be useful and easier. But again, you can see there is a box here called labels in the first row. Basically, Excel asks me whether there is in this column value that you don't want me as Excel to use it. Yes, Excel, please don't use the first one. Otherwise, Excel, if we don't check this box, when we push the OK here to analyze the data, Excel will produce error. So it's the best way is to make sure that the data are set in that form. Again, you can see here the output. We didn't select any output. If you look at the output section here, this is where you want the output to be, but before selecting where we want to be, let us tell Excel what we need to produce. There are 4 options here. The most popular option is the first one, the second one. You don't need to look at the last 2. You can always select them later on, but for the purpose of this video, it's enough to select these 2. So summary statistics, you can imagine that we're gonna get a bunch of metrics. But again, here the output, where the output should be. Of course, if you leave it to the default here, Excel is going to create a new sheet. They call it sheet 1, sheet 2, or whatever. But it's better to name it if you want to produce it in different sheet. But in my case, I don't want to have the result in a separate sheet from the data. I want the result to be on the same sheet here. So I'm going to select here output range. And all what I need to do is to select where. So I'm going to select this box here. I'm going to select E to start the analysis here, exactly here. So I'm going to go ahead here, go back. So it looks like everything is set. So you can pay attention here if you want to have this video, you can pause it at this point to know exactly what I have selected. So after I did that, I'm gonna go ahead and push OK. Once I select OK or push OK, of course my computer is a little bit slower, but it's good for you not to feel like I'm running. So, but in your computer maybe it could be faster here. So you can see here X19 Excel produces a very basic formatted table, but producing a lot of metrics. We call them metrics here. So those are metrics. So I'm gonna call them metrics here, but later. So those metrics, and we can call them those guys values. So for the mean, so it's not really big deal from maybe high school. You know what the mean is, but maybe the median as well, maybe the mode, maybe you heard about standard deviation, the variance before. Definitely you heard about range, which is the difference between minimum and maximum value, that you heard about that before. The sum, which is the total of the whole data that we have. Count is number of data points. We have here 100. So basically, more than half of that, but that we're gonna talk about that later in another video. But the rest maybe you didn't, like kurtosis, skewness, standard error, as well as confidence level. Maybe you heard that in some of lectures, but maybe you don't remember why we did that action, why we did them. If you can see here, if I go here to the average here is 6.918, which maybe it's an indicate. It indicates basically that out of 10, because the scale is from 0 to 10 here, the maximum value was 9.9, which is basically very fantastic value. Someone gave us 9.9 out of 10, but there are also customers who rated us very low grade here, or rate 4.7. The difference between maximum and minimum is this value, 5.2, right? So what does it mean? Yeah, it doesn't mean much now, but at least it tells us this is the range. Maybe we can use it later on. But if we go back to the average here, it looks like, yeah, we expect that we should be better than that, to be honest. Yeah, if we get something less than 7.5 or 8, it means customers are not satisfied. But this is not us to decide. We need to benchmark this value against the benchmark. So later on in one of the videos, if you go back to the variable here and you go to the X19, you can and scroll here, you find that there is kind of a value called 7.2 as a benchmark. Benchmark is the benchmark of the market, which means customer expects 7.2 or more in order to be satisfied. But in our case here, our average is 6.9, which obviously our customers are not satisfied. Whether this difference is big or small or significant or not significant, this is definitely a topic that we have to discuss later on. But again, the purpose of this session, or at least video, during this week is just to give you a very simple introduction, but we're going to go deeper on each of these later on. Okay, so before I finish this video, I would like to basically show you something interesting here. You can see here these values. If I go to any of these cells, you see here in this function bar just values. They are not function, so they are fixed. That means Excel has calculated for us. So basically, if I change any values here, nothing is going to change here. So that's not really pretty, but we like to make it dynamic a little bit. So in order to make it dynamic, I would like to do the following for you guys. So let me, for the same data here, I'm gonna call this here this cell here G1. I'm gonna call the header. It's nothing but get the same value here. So let me give it a color. simple color, make it a little bit yellow, and with a black bolded uh, text here. And I'm going to call this here values or analytics. Obviously, they are descriptive, so analytics. And here I'm going to use the built-in function in Excel in order to make it dynamic instead of having fixed here. But in order to show you this, I'm going to also show you the formula that I'm going to use. Formula. Okay, so let me make those guys a little bit different from the rest of the table in order to see clearly what's here. Okay, so and in order to gain more space, let me make this. If we need it, we'll bring it back. Here, I'm going to write here average function. There is an average function in Excel. I'm going to go very quick here. You don't need me to go slow because you can always come back to the video. So I'm going to go ahead here, select the column A. So we get the same number here. Here there is an interesting formula text function in Excel to show you basically what did I write here. So this is what I wrote here. So you don't need always to know exactly. You don't need to look at here. So for standard error, forget about it now. The median, there is a function called median, and I'm gonna give it the input, the data, our data. So let me control copy, control V here. Let me do it for as many as I want, because I'm gonna show you how each function I'm going to do this. Yeah, I should have basically grabbed it down here, but anyways, just to know what I'm doing. So now the mode, it's easy as well. There is a function called mode. Definitely, we're gonna sorry guys, we're gonna discuss that later on. What's the meaning of mode, the median, and so on, right? So just to show you something on Excel to make life easier for you when you get this sheet later on or file. Standard deviation, there is a function called sddev here. And you find this, Excel has two versions from standard deviation, one .s, which I selected, and there is another one for .p, p for population. But definitely we are going to use the s because we are dealing with sample and not. So we get the same day. So I want always you guys to make it bigger here to see exact number here. Make comparison between what Excel calculated for us as a fixed, but this is became dynamic. Why? Because it means if I change any value here, this will not change because they are fixed, but these guys will change. So sample variance here, there is a function called variance, .s for sample, and the data lives in column A. Kurtosis, yes, even we didn't talk about it, and we will talk about it at the perfect time. So I'm gonna also calculate the kurtosis, and there is also skewness. Just giving you a kind of introduction about Excel, what kind of interesting things we can learn from it. So first I need, before calculating the range, which is the difference between maximum and minimum. So it's basically if you want me to write more. Sometimes Excel doesn't give us really the best description. So I'm gonna write here maximum minus minimum. So I need to calculate the minimum value first. So there is a function called min, and definitely for our data here. And you can always, very easy to guess, max for the same data. Now I can make the very simple subtractions, maximum minus minimum. Definitely I get the same value here. Sum is easy. There is a function called sum, which is the total data that we have. And we can also get the count. There is a function called count A, and we're gonna get the function here. So they are O. So actually count without A, because A is only for text. So we get 100 here. Yeah, without really explaining to you how the standard error is being calculated, which again will be a subject for one of the late lecture at the end of the semester, It's basically we take the standard deviation here and divide it by the square root of the sample size, which is the 100 here. Again, as long as we get the same number, then the function is correct. What does it mean, how we got them? Don't worry about that. Again, this one, don't look at it, just to only to complete it. I'm gonna write it here, but this will also be another advanced topic. So I'm gonna write here the functions called t.inv, and here I'm gonna put 5% and the n minus 1 here, and this I'm gonna divide or multiplying by the standard error here. Again, don't worry about this. The only thing I want to show you that we can really do a lot of things using Excel. Excel did it for us. You see, Excel did that for us in seconds, but we had to write it by ourselves here. The bad thing about what we have done here, we took a little bit of time, but the good thing is it became dynamic. The bad thing about this one, it's Excel did it very quick, but the bad thing is it's fixed. Now if I try to change anything here, let us say I will write here 10, everything changed in this column, but nothing here, right? So I'm gonna take it back by Control Z. Okay, this is one of the interesting things that we can really do here, but I can do two other things here to make it really interesting for you guys. It's a graphical representation. I'm going to show you two very quick graphical representation of our data, because this numerical representation, one of the thing is after I select a column, I can go ahead here and insert chart. So once I push the insert here, I need to see which chart type I need here. So in the middle, exactly in the middle, you will see what I call insert statistic chart. If I go on the top of this, and then I find two things here, histogram or box plot. So this is exactly what I want to show you guys. So box plot here. This is the histogram, and histogram is really interesting distribution function. I'm gonna show you here how we do this. So let me again try to make it a little bit smaller to see a little bit more here. So this is basically Excel decided to get this range 5.2 and split it into segments like you see in front of us. This segment we can actually, let me remove that, and I can add the values. So if I push the bottom plus here, I'm gonna get some more options. So for the element of the chart, so I'm gonna use the label, data labels here. Once I push data labels, I can get the numbers here. So those are numbers representing how many people in each of this segment. And usually we call this segment as bins or classes. So Excel call them bins, so I can really make them bigger like that. Excel used its own, but we can change the depth here or the width of each one. So if I click on the x-axis here and I control 1, I'm gonna push control 1 as a shortcut, then I get more options here. In more options, you can see immediately Excel gave us automatically calculated the bins, but if we need the bins width to be changed, I can push it here. If I want to change the number of the bins, so for instance the bins here, if I take it far here a little bit, they are already let me go back here. So here basically you can see there are 6 of them. If you want more, or at least if you change the width is 0.9. Excel decided to use 0.9. You can see here from 4.7 to 5.6. The width is 0.9, 5.6 to 6.5 is another 0.1. If you think, no, I want it to be 0.5, then you can easily change it and press enter. You get this distribution. And Excel will recount for each bin how many people in each bin. So we have customer who rated us, 8 of them rated us between 4.7 and 5.2, and we have 0 customer here rated us between 9.2 and 9.7, but we have only one customer. If you remember, this was the maximum guy between 9.7 and the 10.2. We don't have more than 10, but Excel doesn't know that we are dealing with this. So this is a histogram, which is really very helpful to show you how our customers are distributing all over the rates. Another interesting graph that I want to share with you, it's called box plot. Let me see here, box plot. I go again, select the data, insert, go back to the statistical techniques here and use box and whiskers. So definitely I can really change it a little bit. I don't need all of these grids here here. I don't need all of this. Even I can change the color. Again, I select any element and control 1. Then I go here and in the fill, I don't need any fill, just to make it clean like that. So this is it. So what does it mean? I'm gonna discuss with you later on when we come to this point. What does it mean? Okay, so let me grab this one here. Yeah, a little bit here. Let me shift to the right a little bit so I get this beside that. So it looks like we have an interesting graph here. Two graphs. One is box plot and the other one is called histogram. The interesting thing now is to know what would happen if, let me hide these things here to get more space for you, hide, just to see more here. And also, let me make this a little bit smaller. Yeah, okay, I want you guys to see the box plot and the histogram here. So now this is the data, they are dynamic. The beautiful things here, if I want to change my data, so I want to grab another column from the data set, let me go now. So I'm gonna go ahead here, go to the data set. And now instead of using X19, why not use the first independent variable, which is X6. So I'm gonna select X6 here, Control copy, go back to my sheet, and here I just paste it. So once I paste it here, you see here it's not changing because this is actually for X19, but now the new data are for X6 because I changed here you see it's changed automatically. So everything is automatic here, guys. I think it's a very interesting to build dynamic data analysis like that. Of course, those things and these numbers and this graphic can later on be used to build a dynamic dashboard for your company. So whenever you change your data here, let me get it back, Control Z, so we are back to the dependent variable. So I'm gonna finish here. I'm gonna upload the sheet as well in order to see the sheet with this video together. So thank you very much and see you in another video.